Hi friends, my name is Maruti and I'm the co-founder of Kraku. In this video, we'll be looking at 25 geometry questions for CAT. Geometry is an extremely important topic in the quant section. Many people spend a lot of time in improving themselves in geometry. All of these questions are taken from the previous papers of CAT. In my opinion, one of the best sources of preparing well for CAT is the previous papers. So definitely download the PDFs of the previous papers. All of them are available for free on our Kraku website. You have to just Google search Kraku CAT previous papers and you'll get to our site where there's a list of all the recent previous papers. Download the PDFs and keep them with you and try to attempt a few questions every single day. If you are not able to get the question in the PDF, you will find the text solution, so you should definitely look at it afterwards. But initially, try to get those questions correct on your own.
In this question, it is given that ABCD is a rectangle. AE is equal to EF is equal to FB. We are required to find out the ratio of the triangle CEF, that is CEF, to that of the rectangle ABCD. So let us assume that the height of ABCD is equal to H and the base is equal to 3B. We would assume this is equal to 3B because we can then easily say that AE is equal to B, EF is equal to B and FB is equal to B. Therefore, the area of the rectangle ABCD is equal to base into height. In this case, base is equal to 3B into height is equal to H. So this is equal to 3BH. Now if you are looking at the triangle CEF, its base is equal to B. This is quite easily known. And if you look at it, its height is equal to the same as the height of the rectangle. The height will equal H, that is this H. So the area of the triangle CEF is equal to half into base into height. So this is equal to half BH. Now if you are required to find out the ratio of CEF to that of the rectangle, the required ratio is half BH by 3BH. This is equal to 1 by 6. So the required answer is 1 by 6. In this question, it is given that there is a triangle ABC with sides 40 feet, 25 feet and 35 feet. A triangular portion GBC is cut off where G is the centroid of ABC. We are required to find out the area of the remaining portion of triangle ABC. So let us first draw the rough diagram to understand what exactly is given and what exactly is asked. So suppose this is ABC and suppose this is G, which is the centroid. It is mentioned that this triangle GBC is cut off and we are required to find out the area of the remaining triangle. So what we will do first is we will find out the area of the original triangle ABC. Then we will find out the area of GBC, of triangle GBC, and then we will just subtract 2 from 1 to get the answer. Now finding out the area of ABC is very easy. We have all the three sides 40 feet, 25 feet and 35 feet. So S, which is the semi-perimeter, is the sum of all of them, that is 40 plus 25 plus 35 divided by 2. So if you calculate it, this will be 50. Therefore the area of ABC is equal to square root of S into S minus A into S minus B into S minus C, where ABC are the lengths of the sides of the triangle. So this is square root of 50 into S minus A is 50 minus 40, so that is 10, into S minus B is 50 minus 25, that will equal 25, into S minus A is 50 minus 35, so that is 15. So this can be simplified as 5 into 10 into square root of 75. 5 into 10 into square root of 75. Again we can take 25 out of the square root. So this will be 250 root 3. This is the area of triangle ABC. Now we need to calculate the area of GBC. Now one thing we know about the median which passes through the centroid is that the median will be intersected in the ratio of 2:1. It will be divided in the ratio of 2:1 by the median. So if you are looking at, suppose the midpoint of BC is say D. Now draw an altitude from A to BC. I will draw these lines again to get a better understanding. Suppose this is GBC, this is G, this is B and this is C. Suppose this is the midpoint of BC. It looks bad, but just stay with me. and suppose this is the perpendicular. Now extend this further so that this is A, and draw a altitude from A to BC. Now suppose the midpoint is say D, the perpendicular from G, suppose it meets BC at E, and suppose the perpendicular from A meets BC at say F. What we are trying to understand, what we are trying to prove from this is the height of GBC, the smaller triangle, is 1/3 the height of the bigger triangle ABC. So the area of JBC will be 1/3 the area of ABC. This is what we are trying to prove. And this is quite easy to prove, because if you look at it, suppose this is 1 and this is 2, that is GD is 1 and AG is 2, and let the height of GE be H1 and let the height of AF be H2. Now triangle ADF is similar to triangle GDE, because both of them are right angle triangles which share a common angle D. So both of them are actually similar triangles. So H1 by H2 will equal DG by AD. That is, the height of the triangle GBC by the height of the original triangle is equal to GD by AD. Now GD by AD is 1/3, because we know that GD is 1 and AG is 2, so AD will be 3. Therefore H1, that is the height of the smaller triangle, will be 1/3 the height of the bigger triangle. Therefore the area of GBC will be 1/3 the area of ABC. So the remaining part of the triangle ABC will be 2/3 the original area of triangle ABC, which is 250√3. So the required area, which is the area of the remaining part, will be 500 by square root 3. This is the answer. All that we need to solve this is understand that the height of the smaller triangle, the triangle which passes through the centroid, is 1/3 the original height of the triangle. So the remaining area is 500 by root 3. In this question we are told that there is a solid metallic cube. It is melted to form 5 solid cubes whose volumes are in the ratio 1:1:8:27:27. Now let us assume that the 5 solid cubes, the volumes are actually A cube, 8A cube, 27A cube and 27A cube. Now the volume of the original cube will be the sum of all these volumes, because the volumes will not change. So the volume of the original cube will be A cube plus A cube, this is 2 plus 8 10, 10 plus 54 is 64A cube. This is the volume of the original cube. It was divided into 5 cubes of the respective volumes. Now the percentage by which the sum of the surface areas of these 5 new cubes exceeds the surface area of the original cube is. So we will first find out the surface area of the original cube. We will find out the surface area of each of the smaller cubes, and then we can find the answer quite easily. If this is the volume, let us find out the individual sides. So because the volume of the first cube is A cube, the side is A. Similarly the second one also side is A. The third cube, the side is 2A. For the fourth cube the side is 3A, and for the fifth cube the side is 3A. Similarly the side of the larger cube is 4A. Remember that the volume of a cube is equal to S cube, where S is the side of the cube. Now let us calculate the total surface area. Again the formula for the total surface area of a cube of side S is equal to 6S square. So for each one of them let us calculate the total surface area. For A it will be 6A square, again it will be 6A square, here it will be 6 into 2A square, that is 6 into 4A square, so that is 24A square. This is 6 into 9A square, so that will be 54A square. This also will be 54A square. And the total surface area of the original cube is 6 into 4A whole square. So this is 6 into 16A square, so that is equal to 96A square. So the original surface area of the cube is 96A square. The new total surface area will be the sum of all of this. So 6 plus 6 is 12, 12 plus 24 is 36, 36 plus 108 is 144A square. This is the new total surface area. Now the percentage by which this exceeds 96 is 144 by 96 minus 1. 144 by 96 is 3 by 2 minus 1. So this is equal to half or 50%. So the answer in this case is 50%. In this question we are told that ABCDEF is a regular hexagon with side length of 1 centimeter. So let us assume that this is the regular hexagon A, B, C, D, E and F. We are required to find out the area in square centimeters of a square where AC is one side. So we are assuming that AC is one side of a square and we are required to find out the area of the square. We know that area of a square is equal to L square, where L is one of the sides. So if we are able to find out the length of AC, we will easily calculate the area of such a square. We know that AB is equal to 1 and AC is equal to 1. We know that angle ABC is 120 degrees. Because this is the interior angle of a regular hexagon, the angle will be 120 degrees. So we need to calculate the length of AC. We will just draw ABC for ease of understanding this method. Remember that you can use the cosine rule to calculate the length of cosine law to calculate the length of AC, but we will try to not use it because there is a much easier way to calculate it. This is ABC. We know that AB is 1. We know that BC is 1. We will draw a perpendicular from B to C. Let us assume that this is D. Because this is an isosceles triangle, this will also be the midpoint of AC. And this is 60 degrees and this is 60 degrees. This is 90 degrees. So BAD will be 30 degrees. So you can easily figure out that AD is equal to the length of hypotenuse AB into cos 30 degrees. We already know that AB is equal to 1. So AD will be root 3 by 2. That is AD is root 3 by 2. Therefore CD will also be root 3 by 2. And the length of AC will be root 3 by 2 plus root 3 by 2, which is equal to root 3. Therefore the area of the square is L square. So it will equal 3. In this question, we are given that there is a rectangle and the endpoints of the diagonal are 2, 5 and 6, 3. And we are also told that the other rectangle has an equation of the form y is equal to 3x plus c, and we are required to find out the value of c. So suppose that this is the rectangle. This is one of the diagonals and this is the other diagonal. We are told that one of the endpoints of one of the diagonals are 2, 5 and 6, 3. And we are told that the equation of the other diagonal is y is equal to 3x plus c. We are required to find out the value of c. One of the things that you should notice is that the midpoint of the vertices is common to both the diagonals. So the midpoint in this case will be 2 plus 6 by 2, comma 5 plus 3 by 2. This is equal to 4, comma 4. So the midpoint, which is 4, comma 4, is common to both the diagonals. So y is equal to 3x plus c also goes through the point 4, comma 4. Now we can just substitute the value of 4, comma 4 in this equation to find out the value of c. So 4 is equal to 3 into 4, because x comma y, which is equal to 4, comma 4, is a point on the line, plus c, or c is equal to 4 minus 12, which is equal to minus 8. So the answer in this case is minus 8. The value of c is minus 8. In this question, it is given that ABCD is a quadrilateral which is inscribed in a circle with center O. So suppose there is a circle and ABCD is a quadrilateral within this circle. So ABCD is a cyclic quadrilateral. We know the definition of a cyclic quadrilateral. Whenever a quadrilateral is inscribed within a circle, the opposite angles add up to 180 degrees. That is the definition of a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral add up to 180 degrees. This is the first thing that we should learn in this question. Similarly, the opposite angles, the other pair, also add up to 180 degrees. Now we are given that COD is 120 degrees. So O is the center of the circle. So COD, this is given as 120 degrees. And if angle BAC is given as 30 degrees, so if we connect A to C, this angle is given as 30 degrees. Then the value of BCD is, we are required to calculate the value of angle BCD. So let us first divide BCD into two parts. One, we can calculate the angle OCD, and then we will calculate the angle BCO. Then we can sum up the value of BCD. Calculating the angle OCD is quite simple. If you look at only the triangle O, C and D, two sides of the triangle are the radius of the circle, so they are equal. And because the angle at the center is 120 degrees, the other two base angles will equal, and they will equal 180 degrees, which is the total sum, which is the sum of all the angles in a triangle, minus 120 by 2, so this is equal to 30 degrees. So angle OCD is 30 degrees and angle ODC is 30 degrees. Now we need to calculate the angle BCO, that is this angle. We don't know that as yet, but remember that it is given that angle BAC is 30 degrees. Once you know that angle BAC is 30 degrees, the angle BOC will be twice the angle 30 degrees. So this will be 60 degrees. Why is that the case? Because the second thing that you should know over here is that angle subtended by a chord at the center will be twice what it is subtending at the circumference. This is true for any chord. So if you are looking at a circle and there is a chord, and if the angle subtended by the chord at the circumference is x, then the angle that the chord subtends at the center will equal 2x. This is true for any chord. So if you are looking at the chord BC, the angle that it subtends at the center will be angle BOC, and the angle that it is subtending at the circumference is angle BAC. If you know that angle BAC is 30 degrees, then it would imply that angle BOC is 60 degrees. Now if you look at only the triangle BOC, here we know that this is 60 degrees, this is O, this is B and this is C. Again over here, the opposite sides are the radius of the circle, so they are equal. So the apex angle is 60 degrees, so we can easily calculate the base angles, because it will be 180 minus 60 by 2, so they are equal to 60 degrees. So if you are looking at the triangle OCD, we know that this is 120 degrees, so the base angles are 30 degrees and 30 degrees. And we know that angle BCO is 60 degrees. So when we want to calculate the angle BCD, it will be the sum of 60 plus 30, so that is equal to 90 degrees. So angle BCD in this case is 90 degrees. We have learned two things. One is that in a cyclic quadrilateral, the opposite sides add up to 180 degrees. And the second one is in a circle, the angle subtended by any chord at the circumference will be half the angle that it subtends at the center. So if this is x, this will be 2x. So the answer in this case is 90 degrees. In this question it is given that there is a circle and two parallel chords on the same side of the diameter have lengths 4 centimeters and 6 centimeters. So let us draw the circle first. Say this is the circle, this is the center, then there are two parallel chords, and the length of both the chords let us name so that it is easier to remember, A, B, C, D, and let the center of the circle be O. Now we are told that AB is parallel to CD. We are also told that the length of AB is 4 centimeters and the length of CD is equal to 6 centimeters. If the distance between these two chords is 1 centimeter, so we are told that the distance between these two is 1 centimeter. We are required to find out the radius of the circle in centimeters. So whenever you are given a chord and the center of the circle, one of the first things that you should do in most of the cases is connect the center of the chord with that of the center of the circle. This will be a right angle. So the theorem is that if there is a circle and if there is any chord in the circle, if you connect the center of the circle to the midpoint of the chord, it will be a right angle triangle, right angle. So we'll do the same thing over here also, because then it makes things very easy. Now we know that OD is equal to the diameter. We also know that OB is equal to the diameter. Let the diameter be equal to R. Now let both the points, both the midpoints of both the chords be equal to, say, P and Q. We are given that this 1 centimeter is equal to the length of PQ. Now if you look at it, there are two right angle triangles. One is OBP, which is the radius, the midpoint of one of the chords, and joining the center to it. So that will be one right angle triangle. And the second right angle triangle is OQD. This is the second right angle triangle. Now we will use Pythagoras theorem to find out the value of R. Let us assume that the length of OQ is equal to P. Therefore, in right angle triangle OBP, that is OBP, R square, R is the hypotenuse, the radius is the hypotenuse, is equal to OP square plus PB square. Now OP is equal to OQ plus 1, because we already know that the length of PQ is equal to 1 whole square plus PB square. Now we know that PB is equal to half of AB. So the length of PB is equal to two centimeters. The length of PB over here is 2 centimeters, and the length of OP, that is this, is equal to P plus 1. Therefore R square is equal to P plus 1 whole square plus PB square, that is 4. Similarly, in triangle OQD, in the smaller right angle triangle, so to say, R square is equal to OQ square plus QD square. Now again QD is equal to CD by 2, so this equals 3 centimeters. We are saying this is equal to 3, and the length of this we assumed is equal to P. So R square is equal to P square plus QD square, that is 3 square, that is equal to 9. So in these two equations, because R square is common, P plus 1 whole square plus 4 is equal to P square plus 9. We can simplify this, we can cancel P square on both sides, so this will become P square plus 2P plus 1 plus 4 is equal to P square plus 9. We can cancel P square, and 1 plus 4 is 5. So if you subtract 5 from 9, this will become 4. So P is equal to 2 centimeters. Therefore R square is equal to P square plus 9, P is 2, so this will be 4 plus 9, this is equal to 13. So the value of R is equal to square root of 13. Now the only thing that we need to know to really solve this, other than Pythagoras theorem, is that if you connect the center of the chord, the midpoint of the chord, to the center of the circle, it will be a right angle. So once you know this and you connect the center of the chords, both the chords, you just need to apply Pythagoras theorem twice to find out the length of the radius as well as the length of P, which is the length of OQ. Once you find that, you are going to find that the radius of the circle is square root of 13 centimeters. In this question, it is given that ABC is a rectangle which is inscribed in a circle of radius 13 centimeters. So let us first draw the circle. Once you draw the circle, you draw the rectangle in the circle. Now this is the rectangles. Let this be A, B, C and D. Which of the following pairs can represent in centimeters the possible length and breadth of ABCD? So let AB be the length, which is equal to L, and let AD be the breadth, which is equal to B. So we are required to find out which of the following pairs can represent L, B. Now the first thing that you should draw is draw the diameter. The diagonal of a rectangle which is inscribed inside a circle will be the diameter. Why will this be the diameter? Because if you draw a circle and when you have a diameter, if you connect any two points to the center, this angle will be 90 degrees because the diameter subtends 90 degrees at the circumference. So when you connect the diagonal, it will be the diameter of the circle. Now you know that the length of the diameter is 26 centimeters. So diameter is equal to 2 into radius, which is equal to 26 centimeters. Therefore the length of BD is equal to 26 centimeters. Now you already know that because this is a right angle and this is 90 degrees. We will use Pythagoras theorem in this case also. So L square plus B square is equal to BD square because ABD is a right angle triangle. Therefore, L square plus B square is equal to D square, or L square plus B square. We know that BD is equal to 26. So 26 square is 676. Now we have to find out which of the four pairs the sum of the squares will equal 676. Let us start with D. 24 square plus 12 square is equal to 24 square is 576 plus 12 square is 144. So the sum of the squares will be 0, 1, 7 plus 1 is 11 plus 1 is 2. So it will be 720. So this is not the answer because we need the sum of the squares to equal 676. If you look at C, 25 square plus 10 square will equal 25 square is 625 plus 10 square is 100. So this equals 725. So option C is also not the answer. Now let us look at option B. It is 25 square plus 9 square. 25 square is 625 plus 9 square is 81. So sum of the squares will be 607, 706. So even this is not the answer. Now let us look at the final option, which is option A. 24 square plus 10 square is equal to 576 plus 100. This is equal to 676. This is actually what we want. We want the sum of the squares of the length and the breadth to equal 676. So the answer in this case is option A. In this question, it is given that there is an equilateral triangle T1 with side equal to 24 centimeters. So suppose this is the equilateral triangle T1. The length of the side L is equal to 24 centimeters. A second triangle T2 is found by joining the midpoints of the sides of T1. So the midpoints of the sides are these, and once you join them, you are going to get a smaller equilateral triangle. This is called T2. Similarly, a third triangle is formed joining the midpoints of the side of T2, and the process continues. We are required to find out the sum of the areas of T1 plus T2 plus T3 plus dot dot dot. What we will try to find out is, we will try to see if there is some sort of a pattern that is possible, wherein we can get a relationship between T2 and T1, that is the area of T2 and the area of T1, and the area of T3 and the area of T2, and so on. Then we can find out the sum of the areas of T1, T2, T3 and so on quite easily. Now if you look at it, this is a smaller equilateral triangle, and the length of each side of this equilateral triangle, if the side of the bigger equilateral triangle is A, this is A by 2 and this is A by 2. Similarly, this will also be A by 2 and this will also be A by 2 because these are the midpoints. This is also equal to A by 2 and this is also equal to A by 2. So, and this is 60 degrees. So the smaller triangle T2 is also an equilateral triangle, and the length of the side of the smaller triangle is exactly half the length of the larger triangle. So the area of T2 will be exactly 1/4 the area of T1. This is because each side of T2 is half the side of T1. The area of T2 will be 1/4 that of T1. Similarly, T3 will be equal to 1/4 of T2, and T4 will be 1/4 of T3, using the same logic. That is, as we keep going further and further, every consecutive triangle will have 1/4 the area of its predecessor. You can even look at it pictorially. So if you look at it, there are 4 equilateral triangles within T1 and each of them is exactly equal to the other. So this is the first equilateral triangle, this is the second equilateral triangle, this is the third equilateral triangle, and T2 is the fourth equilateral triangle. So the area of T2 is 1/4 that of T1. You can find that in multiple ways. Now when we are required to find out the value of T1 plus T2 plus T3 plus so on, this is actually equal to T1 plus T2 is equal to 1/4 of T1 plus T3 is equal to 1/4 of T2, but because T2 itself is equal to 1/4 of T1, this will be 1/16 of T1 and so on. So this is a geometric progression where the common ratio is 1/4. So this is an infinite geometric progression where the common ratio is 1/4. Now whenever you have a geometric progression where it is AR square and AR cube and so on, where the terms are where the first term is A and the common ratio between two consecutive terms is R, the sum of such a geometric progression where the number of terms is infinite is A by 1 minus R. Note that R has to lie between -1 and +1. That is, the consecutive terms have to continue to become lesser and lesser. At least the absolute value of the consecutive terms has to continue to decrease. In that case, the sum of the geometric progression is A by 1 minus R. In this case, the first term of the geometric progression is T1. The area of T1 we can easily calculate because we know the side, the length of the side, and the common ratio R is equal to 1/4. Therefore, the total area of T1 plus T2 plus T3 and so on will equal T1 by 1 minus 1/4. This is equal to 4/3 into T1, where T1 is the area of the bigger equilateral triangle. Now the area of the bigger equilateral triangle is √3/4 into a square, which is 24 into 24. Remember that if there is an equilateral triangle of side A, the area of the equilateral triangle is √3/4 into a square. In this case, we know that A is equal to 24. So this is the area of the biggest equilateral triangle, that is T1. Now we are required to find out 4/3 into this area. So the required answer is a simplification of this calculation, √3/4 into 24 into 24 into 4/3. If you simplify this, 24 into 24 is 576, 576/3 is 192. So the required answer is 192 into square root of 3 square centimeters. So the answer is 192 √3. The first thing that you should observe is each triangle, the area of each subsequent triangle is 1/4 the area of its predecessors. Once you understand that, finding the value of T1 plus 1/4 T1 plus 1/16 T1 and so on is very easy. In this question, it is given that there is a right circular cone. The height of the circular cone is 12 feet and it stands on its base with a diameter of 8 feet. So this is how the cone is. It looks like a triangle from one side. So the height has been given as 12 feet. Now the radius is given as 4 feet. We are told that the diameter is 8 feet, so the radius is 4 feet. The tip of the cone is cut off with a plane which is parallel to the base and 9 feet from the base. So at a height of around 9 feet, so this is given as 9 feet, a plane is cut off. So a cone at the top, this small cone is cut off from the larger cone. Now with pi as 22/7, in cubic feet we are required to find out the volume of the remaining part of the cone. The remaining part of the cone is basically a frustum. So we are required to find out the volume of this part. Now what we will do is we will first initially calculate the volume of the larger cone. Then we will calculate the volume of the smaller cone, that is this cone, and the volume of the remaining part of the cone is just subtracting the two volumes. From the larger cone we will subtract the volume of the smaller cone. Now let us revise that the volume of a cone is equal to 1/3 into pi into r square into h, where r is the radius of the cone and h is its height. Now so calculating the volume of the larger cone is quite easy. We know that the radius is 4 and the height is 12. Now to calculate the volume of the smaller cone, do we know the height? We know the height is actually equal to 12 minus 9. This is equal to 3 feet. So the height of the smaller cone, this part is 3 feet. This we know quite easily. Now what is the radius of the smaller cone? The radius of the smaller cone we'll have to calculate. Now we'll draw a perpendicular line from the tip of the cone, that is the topmost point, to the bottom. So here we know that this is equal to 3 feet. We know that the area of the larger one is equal to 12 feet. We know that the radius of the larger cone is equal to 4 feet. We are required to find out the area of the radius of the smaller cone. You can calculate it by using simple property of similar triangles, because the smaller triangle is similar to the larger triangle. All their sides are in proportion. Therefore, this small r by 3, which is the height of the smaller cone, is equal to 4 by 12, which is the height of the larger cone. Using this, you can calculate that the radius of the smaller cone is actually equal to 1 feet. So now calculating both the volumes is quite easy. So volume of the larger cone is equal to 1 by 3 into pi into r square, where r is 4 into 4 into the height, which is 12. So 4 into 4 is 16, 16 into 12 is 192. So this is equal to 192 into pi by 3. This is the volume of the larger cone. Now volume of the smaller cone can be again calculated using the same formula. This is equal to 1 by 3 into pi into what is the radius of the smaller cone. We have just calculated that the radius of the smaller cone is 1 feet. So r square is 1 into 1 into what is the height of the smaller cone. The height of the smaller cone is 3. So this is equal to 3 into pi by 3. Therefore, the volume of the remaining part of the cone is volume of larger cone minus volume of smaller cone. So this will be pi by 3 into 192 minus 3. This is pi by 3 into 189. 189 by 3 is 63. So the required answer is 63 pi. But because they have given us that the value of pi can be approximated to 22 by 7, we will use that. Again 63 by 7 is 9. So the answer is 22 into 9. Now 22 into 9 can be easily calculated as 198. So the required answer is 198 cubic feet. So we can easily input that. To do that, we will have to first figure out that to solve this question, that to calculate the volume of the remaining part of the cone, we just have to subtract the volume of the smaller cone from the volume of the larger cone. The second complexity over here is figuring out the radius of the smaller cone. You should understand that the radius and height of both the cones are in proportion, because the plane which is used to cut off the smaller cone is parallel to the base. So once you figure it out that the radius of the smaller cone is 1 feet, calculating the volume of the smaller cone and volume of the larger cone is quite straightforward.
Google search crack your free CAT marks. Click on the first link. You can attempt 3 latest mocks in the actual exam interface. After completing the test, you get detailed solutions, analysis and percentile along with your scorecard to gauge your All India performance. Click on the solutions to get video solutions from our expert faculty.
In this question, it is given that there is a parallelogram ABCD of area 72 square centimeters. So let us draw the parallelogram. This is the parallelogram. This is ABCD. The area of the parallelogram is 72 square centimeters. It is given that sides CD and AD have lengths 9 centimeters and 16 centimeters. So CD is 9 and AD is 16 centimeters. Let P be a point on CD such that AP is perpendicular to CD. So let P be a point such that AP is perpendicular to CD. So this is right angle 90 degrees. Then the area in square centimeters of triangle APD is. We are required to find out the area of triangle APD. It is a right angle triangle. We know the length of the hypotenuse, it is equal to 16 centimeters. So if we can figure out one of the lengths, that is either the base or the height, we can easily calculate the other side because using Pythagoras theorem. Then we can calculate its area easily. Now to find out the sides, you can notice that this is a parallelogram and the height of the parallelogram is actually equal to AP and the area is equal to base into height. So whenever you have a parallelogram, if the base of the parallelogram is B and the height, this height is equal to h, then the area is equal to B into h. Notice that we are looking at the height, we are looking at the perpendicular from the base to the other side, the parallel side. We are not looking at the length of the parallel side. We are only looking at a perpendicular from the base, that is this line, which will intersect the other parallel side. That is called the height. In this case, the height is equal to AP. That is, in parallelogram ABCD, the height is equal to AP and the base is equal to CD, and we know the length of the base, this is equal to 9 centimeters. So the area of the parallelogram will be base, that is 9 into the height, which is AP. We know that the area is 72. So 72 is equal to AP, which is the height, into the base 9. Using this, you can easily calculate that the length of AP is equal to 8 centimeters. Now once you know the length of AP, you can calculate the length of PD, because this is a right angle triangle in which the hypotenuse is equal to 16 centimeters. Therefore, the length of PD is equal to square root of 16 square, which is the length of the hypotenuse, minus 8 square, which is the length of one of the sides. 16 square is 256, minus 8 square is 64. You can easily calculate that this will equal 8 root 3. Now we know PD, which is one of the base, and we know the length of the height also, that is 8 centimeters. Therefore, the area of the triangle is equal to half into AP into PD. This is equal to half into 8 into 8 root 3. This is equal to 32 root 3 square centimeters. What we have done in this question is quite simple. We know the area of the parallelogram, we know the base. So once we know the base, we have calculated the height of the parallelogram. Once we calculated the height, we have calculated the length of the base of the triangle APD using Pythagoras Theorem. Once we have the height of the triangle and the base of the triangle, because this is a right angle triangle, you can easily calculate its area, and this will equal 32 root 3 square centimeters. In this question, it is given that there is a parallelogram ABCD of area 48 square centimeters. So let us assume that this is the parallelogram. This is A, this is B, this is C, and this is D. We are told that the length of CD is 8 centimeters and the length of AD is equal to S. Then which of the following is necessarily true? So if you look at the options, we are required to find out the range for S. So we are given that the area of the parallelogram is 48 square centimeters and we are given the length of the base, this equals 8 centimeters. So we know that the area of a parallelogram is equal to base into height. So what exactly is height? Height is the length of the perpendicular that is drawn to the base from one of the vertex. So let us assume that this is equal to h. What we are given is that 8 into h, 8 is the base and h is the height of the parallelogram, is equal to the area, which is 48, or we are told that h is equal to 6 centimeters. So basically we are given a parallelogram where the height of the parallelogram is 6 centimeters. We are required to find out the range of S. Now suppose the point at which the perpendicular is dropped on CD is E. Now if you consider triangle ADE, this is a right angle triangle. In this we know that the height of the triangle, that is one of the sides of the right angle triangle, is 6 centimeters and we are required to find out the range of S. S is the hypotenuse of the right angle triangle. So hypotenuse will always be the longest side of the right angle triangle. So we know for sure that S is greater than or equal to 6. Should S be always greater than 6? That is not necessarily true, because every rectangle is also a parallelogram. So if the parallelogram that is mentioned is like this, where this is 8 and this is S and this is already a right angle, then the value of S over here will equal 6 centimeters. What we know for sure is that S has to be greater than or equal to 6, because S has to be greater than or equal to the height of the parallelogram, or in this case the height of the triangle. So if you look at the options that are given, one of the options, for example option D, is S is less than or equal to 6. This is definitely not true. The second one is S is not equal to 6. This also is not necessarily true, because as we discussed earlier, if it is a rectangle, then S will equal exactly 6. The third one that you can strike out is option C, which says that S has to lie between 5 and 7. This is also not necessarily true, because S first of all cannot be less than 6. So S can't exist between 5 and 6, and there is no necessary upper limit for S. For example, if the parallelogram that we are considering is very acute, in a case where, say, this is the parallelogram, where the angle ADA, if this is very low, then the length of S will be very large. The height will ultimately come down to 6, but the length of the hypotenuse can be very large. So there is no necessary upper bound for S. So we can even strike this out. The only correct answer over here is that S is greater than or equal to 6. This is something that we can say for certain. We know that S has to be greater than the height of the parallelogram, which is equal to 6. So the correct answer in this case is option B. In this question, it is given that there is a chord of length 5 centimeters. It subtends an angle of 60 degrees at the center of the circle. So suppose this is the circle. Now there is a chord, and this is the center of the circle. Suppose that this chord is subtending an angle of 60 degrees, and the length of the chord is given as 5 centimeters. Now whenever you are told that there is a chord which subtends 60 degrees, or if you are told that there is a triangle, in this case it is an isosceles triangle because both the radii are equal. So whenever you are told that there is an isosceles triangle and the angle between the equal sides is 60 degrees, you can be sure that this is an equilateral triangle, because when this is an isosceles triangle, the base angles will be the same. Let us assume that they are equal to A. Therefore 2A plus 60 degrees will equal 180 degrees, which is the sum of all the angles of a triangle. Or you can infer that A will also equal 60 degrees in this case. So all the three angles will equal 60 degrees, and hence it is an equilateral triangle. So in this case also, because it is given that the length of the chord is 5 centimeters and it subtends an angle of 60 degrees, this will be an equilateral triangle, and the radius of the triangle, the radius of the circle, is equal to 5 centimeters. Now the length in centimeters of a chord that subtends an angle of 120 degrees at the center of the same circle is. So we are required to find out the length of another chord, but this one subtends an angle of 120 degrees at the center. So as we have discussed earlier, the radius of the triangle is 5 centimeters, and this chord subtends 120 degrees at the center. So let us assume that the length of this chord is equal to x. Let us draw a perpendicular from the center to the center of the chord. Again, you should remember that whenever there is a circle, if there is a chord, the perpendicular from the center of the circle to the chord will bisect the chord. So whenever you are drawing a line from the center of the circle to the midpoint of the chord, it will be 90 degrees. So over here, the length of, so suppose this is O, this is A, this is B, and this is C. So in triangle OAC, the length of AC is equal to x by 2. As we have discussed earlier, this will be the midpoint of the chord, and we know that the angle is bisected. So angle AOC is 60 degrees, because the bigger angle, that is angle AOB, is equal to 120 degrees. Therefore we can infer that the other angle is 30 degrees, because this is a right angle triangle. What is this angle? This angle is angle OAC is equal to 30 degrees. Now you can easily find out the value of x by 2 in multiple ways. For example, in this case, x by 2 is equal to 5, which is the hypotenuse, into sine 60 degrees. So if you are considering this angle, in this triangle, the triangle OAC, the hypotenuse is 5 centimeters, the length of the base is x by 2, and this is 60 degrees. So you can easily find out that x by 2 will equal 5 into sine 60 degrees. Sine 60 degrees is equal to 5 into root 3 by 2. You can cancel the denominator 2 on both sides. Therefore the length of x will be 5 root 3. That is, the length of the chord AB will be 5 root 3. There are a couple of things that we have learned in this question. One is that when there is a triangle, an isosceles triangle, and the angle between the equal sides is 60 degrees, it is an equilateral triangle. The second thing which you should remember is whenever you draw a line from the center of the circle to the midpoint of any chord, it will be a perpendicular line to the chord. Once you know these two things, finding the value of the chord will be very straightforward, which in this case is 5√3. In this question it is given that there is a rectangle. The area of the rectangle and its perimeter, the square of its perimeter are in the ratio 1:25. So let us first look at the rectangle. Say this is the rectangle. Let the sides of the rectangle be A and B. Therefore the area of the rectangle will equal AB, and the perimeter of the rectangle will equal 2 into A plus B. Therefore the square of the perimeter will equal 4 into A plus B whole square. Now we are told that the area of the rectangle and the square of its perimeter are in the ratio 1:25. So AB by 4 into A plus B whole square is equal to 1/25. This is the equation that is given to us. We are required to find out the lengths of the shorter and longer side are in the ratio. So we are required to find out the ratio of A is to B, where we can assume that A is greater than B. So let us first try to simplify the equation that is given and then try to find out what is needed. So this would imply that 25AB is equal to 4A square plus 8AB plus 4B square, or this will imply that 4A square minus 17AB plus 4B square is equal to 0. Now we are only looking at the larger and the shorter side. We are not really concerned about the exact values of A and B. They can be even interchanged. So without loss of generality, let us assume that A is greater than B, and let A by B be equal to R, and we are required to find out the value of R. Now because A is greater than B, R is greater than 1. So we are actually required to find out the lengths of the shorter to the longer side. So we are required to find out the value of 1 by R. We will keep that in mind while we try to simplify this equation. So we will divide this equation by B square. So it will become 4A by B whole square minus 17A by B plus 4 is equal to 0. Now as we have assumed that A by B is equal to R, this would equal 4R square minus 17R plus 4 is equal to 0. This is a simple quadratic equation in R. You can solve for R and then you can get the answer. In this case, we can factorize this as 4R square minus 16R minus R plus 4 is equal to 0, or 4R into R minus 4 minus 1 into R minus 4 is equal to 0. So this will be 4R minus 1 into R minus 4 is equal to 0, or R will equal 1 by 4 or 4. So as we have assumed that A is greater than B, R will be greater than 1. So the ratio of the longer to shorter side is equal to 4:1. But what is asked over here is the ratio of the shorter to the longer side. So it will be the exact opposite. So the answer in this case will be 1:4. In this question it is given that there is a triangle ABC. The area of the triangle is given as 32 square units. Its side BC of length 8 units lies on the line x is equal to 4. So let us first draw the graph. We will try to understand what this actually represents. So this is the y-axis and this is the x-axis. Now x is equal to 4 is a line over here. This is x is equal to 4. Now on this line lies the side BC. So BC can be anywhere on this line. The length of BC is 8 units. Now the shortest possible distance between A and the point 0, 0 is. So let us first try to find out where the vertex A can lie, because we know the area of ABC is given as 32 square units. We know that the length of BC is given as 8 units. So if you consider ABC to be something like this is A. Just for ease, let us consider ABC to be like this. This is A, this is B and this is C. We are told that BC is equal to 8 units and we know that the area is 32 units. So the perpendicular from A to BC we can easily find out the length of that perpendicular. If you assume that the length of that perpendicular is x, half into x into 8 will be the area of ABC. But this we already know is equal to 32. It has already been given that the area is 32 square units. So this would imply that x is equal to 32 into 2 by 8. You can simplify this and this will be 8 units. So the height of the altitude from A is 8 units. So because you know that BC is lying on the line x is equal to 4, it would imply that because BC is lying on the line x is equal to 4, it would imply that the vertex A lies on either x is equal to 12 or x is equal to minus 4, because you know that the altitude is 8 units. So if you draw the line x is equal to minus 4, it will be something over here. This is the line x is equal to minus 4, and the line x is equal to 12 will lie somewhere over here. Now if you pick any point on any of these lines and BC, the area of the triangle will definitely be 32 units. For example, if you assume that this is point A and you join A to BC, because the height is constant, the height is 8 units and the base length is also 8 units, the area of this triangle will be 32 units. Similarly, if you pick any point over here on the line x is equal to minus 4 and you join it, again because the height is fixed as 8 units, this height, and the base we already know is also 8 units, it would again imply that the area of this triangle is also 8 units. So we need to fix the point A on either x is equal to minus 4 or x is equal to 12. But we have to do it in such a way that the distance between A and origin, that is point 0, 0 is the least. Now for the point 0, 0, the distance is least from x is equal to minus 4 if A is minus 4, 0, in which case the distance is 4 units. Similarly, if you are trying to fix A on the line x is equal to 12, the shortest distance from origin to the line x is equal to 12 will be when A is 12, 0, and in this case the distance is 12 units. Because you are trying to minimize this distance, the answer will be 4 units, and this will happen when A is the point minus 4, 0. Notice that we have finalized that A lies, that is the vertex A lies either on x is equal to minus 4 or on x is equal to 12. Now when A lies on x is equal to minus 4, the shortest possible distance between origin and x is equal to minus 4 is 4 units. This will occur when A is minus 4, 0. If A lies on the line x is equal to 12, the shortest possible distance is 12 units, and this is when A is 12, 0. Because we are trying to minimize it, the answer will be 4 units. In this question it is given that there is a rectangle ABCD and the area of the rectangle is 768 square centimeters. So let us first draw the rectangle. See, this is the rectangle ABCD. The area of the rectangle is 768 centimeters square. Now a semicircular part of diameter AB and area 72 square centimeters is removed. So a semicircle with AB as the diameter and the area is given as 72 square centimeters is removed. Now we are required to find out the perimeter of the leftover portion. So the leftover portion will look something like this. This is ABCD. I am making this look slightly smaller for scale. Okay, so this is A, this is D, this is C, this is B. We are required to find out the perimeter of this part. So what we'll do is quite simple. We'll first assume that the length of AB is L and the breadth of AB is B. So we know that L into B is given as 768 centimeters square. But we are also given that the area of the semicircle is 72 pi. Now for the semicircle, the radius, AB is the diameter, so the radius will be AB by 2, which is L by 2. Therefore the area of the semicircle will be pi r square by 2, but in this case r is equal to L by 2. So this will be pi by 2 into L by 2 into L by 2. This we are told is equal to 72 pi. Therefore you can solve for it and you will find that L square is equal to 144 into 4. So L is equal to 12 into 2, which is equal to 24 centimeters. So now that we know L, we will calculate the value of B. B is equal to 768 by L, which is equal to 768 by 24. You can easily calculate that this is equal to 32 centimeters. Now if you are required to find out the perimeter of this figure, you know that the length of AD is 32, the length of BC is also 32, the length of CD will equal the length of AB, which will equal 24. So you are just required to find out the circumference of this semicircle. Now circumference of the semicircle, circumference of the entire circle will be 2 pi r. This is for the full circle. So the perimeter of the semicircle will be half of it, which is equal to pi r. In this case, r is equal to L by 2. So this will be pi into L by 2, where L is equal to 24. So this will equal 12 pi. So the length of this circular part is 12 pi. Therefore, the total perimeter will be 32 plus 32 is 64, 64 plus 24 is 88, 88 plus 12 pi. So the answer is 88 plus 12 pi.
In this question, we are given that there is a regular pyramid and the base of the regular pyramid is a square. So say this is a pyramid and this is the base of the pyramid. This is a square and each of the other four sides is an equilateral triangle. So this will be in another dimension where there is an equilateral triangle. All this, the other sides of the pyramid, which is basically in 3 dimensions, will meet at an apex, and each of this is a equilateral triangle. The length of each side is 20 centimeters. So for the pyramid, the other 2 sides, the other 4 sides are 20 centimeters each, and they are all equilateral triangles. This would imply that even the base of the triangle, which we know is a square, the length of each side of the square is 20 centimeters. Now notice that the point where they made this is the apex of the pyramid, which is at the top. Now we are required to find out the vertical height of this pyramid. So what we will first do is, for each of the equilateral sides, which is along the side, we will find out the length of the median. So if you are looking only at the equilateral sides, which is one of the sides of the equilateral triangle of the pyramid, we know that it is an equilateral triangle of side 20 centimeters. So along one of those sides, if you draw a line from the apex to the bottom, which is bisecting the third side, that is, which is bisecting the base, the length of this side will be 10 root 3, because that is the median of the equilateral triangle of side 20. You can calculate that quite easily because this is 60 degrees, and so this will be 20 into sine 60, that is 20 into root 3 by 2, so that will be 10 root 3. Now consider just the base of the triangle, base of the pyramid. The base of the pyramid is a square. Now consider the point which is in the middle of the base. Now if you draw a line which is vertically to the top, it will come and meet the apex at some point. So say this is the apex. This is a vertical line of height, say h. Now again along the ground, you are drawing a line from the base, from the center of the base to the side of the pyramid. The length of this side will be 10 centimeters, because the length of the square is 20 centimeters. This will be exactly half of it. Now if you consider the apex as A and the center of the pyramid as C, and the point at which the line meets the side of the square as, say, D, ACD will be a right angle triangle. Now ACD will be a right angle triangle. The height of the right angle triangle is h, as we have just discussed. At the base it will be a right angle over here, and the length of the side along the ground will be 10 centimeters. This is CD. And when you draw a line in 3 dimensions which meets from A to D over here, this will be along the side of the equilateral triangle that we have just discussed, and the length of it will be 10 root 3. Now using this we can actually calculate the value of h, which is the vertical height of the pyramid that we need. Because this is a right angle triangle, h square plus 10 square will equal 10 root 3 whole square, or h square will be 300 minus 100, which is equal to 200, or h is equal to square root of 200, which is equal to 10 root 2.
Now what we have found out is one thing. We have first found out the length of, if you draw a line from the apex of the pyramid to the center of the square, that length will be 10 root 3 directly in 3 dimension. Then we have recognized that if you just consider the triangle where apex is one vertex, the center of the square is the second vertex, and the center of a side of the square is the third vertex, it will be a right angle triangle in 3 dimension. Now the sides will be h, 10 and 10 root 3. Using this you can calculate the value of h, which will equal 10 root 2. This is the answer. In this question we are given that ABC is a right angle triangle with hypotenuse BC of length 20 centimeters. So let us assume that this is the right angle triangle this is B, A and C. We know that BC is the hypotenuse and the length of BC is given to be 20 centimeters. Now we are told that AP is a perpendicular on BC from A. So this is a perpendicular. Now the maximum possible length of AP is equal to, we are required to find out the maximum value of AP. So let us assume that the length of AP is equal to R. We'll try to find out a function, the value of R as as an expression, and then try to maximize the value of that expression. So let us start off by assuming that the length of AB is equal to X, the length of AC is equal to Y, the length of BP is equal to Z. Now if BP is equal to Z, the length of PC will be 20 minus Z. Why would it be 20 minus Z? Because we know that the length of BC is equal to 20. So we are just subtracting Z from 20. Now we will use Pythagoras Theorem multiple times. That is in triangle ABP, x square, here x is the hypotenuse, is equal to R square plus Z square. Similarly in triangle APC, y is the hypotenuse, so y square is equal to R square plus 20 minus Z whole square. Now remember that ABC itself is a right angle triangle. So in triangle ABC, x square plus y square is equal to 20 square, where 20 is the length of the hypotenuse. So if you add the first equation and the second equation, we will get a term x square plus y square. Using substituting 20 square in place of it, we can eliminate both x and y. So that is what we are going to do next. So we will add 1 plus 2, that is these two equations. So x square plus y square is equal to r square plus r square, so that is equal to 2r square plus z square plus 20 minus z whole square. So that will be z square plus 20 minus z whole square. Now x square plus y square is equal to 20 square. So we'll substitute that. So 20 square is equal to 2r square plus z square plus 20 square minus 40z plus z square. This is just an expansion of 20 minus z whole square. Now we'll cancel out the common terms, that is 20 square, and we'll try to find out the value of r square. So 2r square is equal to 40z minus 2z square, or r square is equal to 20z minus z square. Now we'll have to vary z. The value of z can vary from 0 to 20 and try to maximize r square. You can do this in multiple ways. One of the ways that I do most often is by completing of squares. So 20 minus z whole square, I'll add and subtract 100 from both sides. This is equal to 100 minus 100 plus 20z minus z square. The reason I am adding and subtracting 100 is because I want to complete a perfect square. So here r square is equal to 100 minus z square minus 20z plus 100. This is equal to 100 minus z minus 10 whole square. This is the value of r square. So we know that r square is equal to 100 minus a perfect square. The value of a perfect square will be at least equal to 0. So the maximum value of r square will be 100, which will happen when z is equal to 10. So the maximum value of r is equal to square root of 100, which is equal to 10. This will happen when z is equal to 10, or ABC is an isosceles triangle and the perpendicular is actually a median which bisects the hypotenuse. Anyway, the answer that we are looking for is 10. The key to knowing this is knowing how to complete a square and using Pythagoras theorem multiple times. The answer is 10 centimeters. In this question, we are given that AB is the diameter of a circle of radius 5 centimeters. Let us first draw AB. So this is, suppose this is a circle and we have, this is A and this is B, and AB is the diameter. The radius of the circle is given as 5 centimeters. So the length of AB, because AB is the diameter, is 10 centimeters. P and Q are 2 points on the circle such that the length of PB is 6 centimeters. So suppose this is P. The length of PB is given as 6 centimeters. The length of AB is 10. And the length of AP is twice the length of AQ. So the length of AP we'll first find out. And before we get into the calculation of AP, we should know one simple thing. That is, if there is a diameter of a circle and you connect both of them to any point on the circle, it need not be any specific point, it will always be a right angle. So assuming that this is say this is K and L, this is the diameter. If you connect K and L to any point on the circle, they will form a right angle triangle. So for example, even this will be a right angle triangle. Any point on the circle when connected to the opposite ends of a diameter will always be a right angle. This is a theorem which you can remember. So in this case, APB will be a right angle triangle. And the hypotenuse is 10 centimeters and one of the side is 6 centimeters. Therefore, the length of AP will equal, by Pythagoras theorem, square root of 10 square minus 6 square. Again, a very simple thing which most of you would already know is that in a right angle triangle, if one of the side is A and the other side is B, the side opposite the right angle triangle, which is the hypotenuse, the formula is A square plus B square is equal to C square. This is the Pythagoras theorem, which is quite useful. So using this formula, we can calculate the length of AP. This will be square root of 10 square minus 6 square. This will be square root of 100 minus 36, which is equal to square root of 64, which is equal to 8 centimeters. So we know that the length of AP is 8 and the length of AP is twice the length of AQ. Therefore, the length of AQ will be 8 by 2, which is equal to 4 centimeters. So suppose Q is a point somewhere over here such that this is AQ, this is 4 centimeters. Then the length in centimeters of QB is nearest to. So we need to find out the length of QB. Again, using the earlier theorem about a diameter and subtending right angle triangle at on any point on the circumference, here AQB is also a right angle triangle and the hypotenuse is the same, which is 10 centimeters. Here one of the side is 4 centimeters, therefore the length of the other side will be square root of 10 square minus 4 square, which is equal to square root of 100 minus 16, which is equal to square root of 84. This is the length of BQ. And square root of 84, you can use a calculator to find out that this is something like 9.16 centimeters. Amongst the options that are given, the only option which is closest to it is 9.1. So the answer in this case is 9.1 centimeters. In this question, it is given that the corners are cut off from an equilateral triangle T to produce a regular hexagon H. Then the ratio of the area of H to the area of T is, this is what we are required to find out. So suppose there is an equilateral triangle. Suppose this is the equilateral triangle. Now the corners are cut off from the triangle to form a regular hexagon. So suppose this is the hexagon that is formed. Now we are required to find out the ratio of the area of the hexagon to the area of the equilateral triangle, the original equilateral triangle. Let us assume that each of the side of the hexagon is A. Now by symmetry, the part that is cut off from the triangle will also be A. That is, this will be A, 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 and this will be A. Why will it be A? Because you can actually prove that the smaller equilateral triangles that are shown are also equilateral triangles. That is, the smaller triangles, these three smaller triangles themselves are equilateral triangles. It is quite easy to prove that because the angle of the hexagon will be 120 degrees. So all the angles of each of the smaller triangles will be 60 degrees. And the original angle is also 60. So it is quite easy to prove that each of the smaller triangles that are formed are equilateral triangles. So all the sides will be A. So in this old triangle, old equilateral triangle, the length of the side, length of each side is equal to 3A. This is A plus A plus A, 3A. Therefore, the area of the equilateral triangle, area of T, is equal to, we know the formula for the area of an equilateral triangle, which is root 3 by 4 into S square, where S is the length of each side. In this case, it will be root 3 by 4 into 3A square, which will be root 3 by 4 into 9A square. Now we can use the formula to find out the area of the hexagon of side A, but if you are not able to remember it, we'll just calculate the total area of the three smaller equilateral triangles and subtract it from 9A square to find out the area of the regular hexagon. So area of smaller equilateral triangle is equal to root 3 by 4 into A square. Now we have three such equilateral triangles at each of the corners. So the total area that has to be subtracted will be root 3 by 4 into 3A square. Now if we subtract this from the original area, we are going to get the area of the hexagon. So area of hexagon is the first area minus the second area, which will be, we can take root 3 by 4 common, 9A square minus 3A square, which will be 6A square. Now the required ratio that we have to find out is 6A square by 9A square, because we can cancel root 3 by 4. So that will be 6 by 9, the ratio of the area of the hexagon to the area of the original equilateral triangle, which will be 2 by 3. So in this case, the answer is 2 by 3. Once we figure out that each of the smaller triangles formed are equilateral triangles, and then get a ratio of the side of the hexagon to the side of the original equilateral triangle, we can get the answer quite fast. In this question, we are given 2 points, 2, 1 and -3, -4, and we are told that these are opposite vertices of a parallelogram. So in a parallelogram, you have two sides which are, the opposite sides are parallel to each other. So this is a parallelogram, and we are told that we have been given the one set of opposite vertices. We are told that this is equal to 2, 1 and this is equal to -3, -4. We are also told that the other two vertices lie on the line x plus 9y plus c is equal to 0. So let us first connect both the opposite vertices. So these are the diagonals of the parallelogram, and we have been told that this line is x plus 9y plus c is equal to 0, and we are required to calculate the value of c. So both the opposite vertices, if you are calling them to be a, b, c and d, a and c lie on the line x plus 9y plus c is equal to 0. So does the point of intersection of both the diagonals, that is, say, is equal to O. But we know the coordinates of O. O is the midpoint of B and D. So the coordinates of O will be 2 plus -3, that is 2 minus 3 by 2, which is -1 by 2. And the y coordinate will be 1 minus 4 divided by 2, which is equal to -3 by 2. So even O lies on the line x plus 9y plus c is equal to 0. Or if you substitute the coordinates of O in the given line, it should equal 0. That is, the x coordinate is -12 plus 9 times the y coordinate is -3 by 2 plus c is equal to 0, or the value of c is equal to half plus 27 by 2, which is equal to 28 by 2, which is equal to 14. So the value of c is 14. In this question, we are told that there is a trapezium ABCD such that AB is parallel to DC and BC is perpendicular to DC. We are also given the angle BAD is equal to 45 degrees. We are told that DC is equal to 5 centimeters BC is equal to 4 centimeters, and we are asked to find out the area of the trapezium. So let us first draw the trapezium. Let us assume that this is AB, this is BC. BC is parallel to DC, so this is D, and we will get DC something like this, which is perpendicular. And we also are told that angle BAD is equal to 45 degrees. So it will look something like this. This is the trapezium A, B, C and D. BC is perpendicular to DC. Angle BAD is equal to 45 degrees. So this is equal to 45 degrees. We are told that DC is equal to 5 centimeters. So this is 5 centimeters. BC is equal to 4 centimeters. So this is 4 centimeters. And we are asked to calculate the area of this trapezium. In order to calculate the area of a trapezium, you need the length of the parallel sides. You know the length of DC, but you don't know the length of AB. Once you know the length of AB, you will have to take the average of both the parallel sides, that is AB plus DC, and then multiply it with the height of the trapezium. Height is again known. This is equal to 4 centimeters. That is the length of BC. But how do we calculate the length of AB? Let us draw a perpendicular from D to AB. Let us assume that it meets AB at a point E. So DE is equal to 4 centimeters. DE will be the same as BC. So this is equal to 4 centimeters. This is a right angle triangle. So angle ADE will also equal 45 degrees. Or this is a right angled isosceles triangle. So AE will equal DE. So the length of AE will also be equal to 4 centimeters. The length of BE will be equal to the length of DC, which is equal to 5 centimeters. Or the length of AB will be equal to 9 centimeters. The length of DC we know is equal to 5 centimeters. So their average will be half of 9 plus 5, that is half of 14, which is 7 centimeters. Into the height of the trapezium is 4 centimeters. So the area of the trapezium is equal to 28 centimeters square. In this question, we are told that the sum of the perimeters of an equilateral triangle and a rectangle is 90 centimeters. So we have an equilateral triangle, something like this, and we have a rectangle. Let us assume that it is like this. We are told that the sum of these two perimeters is 90 centimeters. We are also told that the area of the triangle, if it is considered to be T, and the area of the rectangle, if it is equal to R, share the relationship R is equal to T square. We are also told that the sides of the rectangle are in the ratio 1:3. So let us assume that the sides of the rectangle are B and 3B. This is 3B, this is 3B, and this is B. And let us assume that each side of the equilateral triangle is say small a. So this is A and A. Now we are required to find out the length of the longer side of the rectangle. That is, we are required to calculate what is the value of 3B. We are given one relationship. We are told that the areas of the rectangle will be equal to 3B into B, so that is equal to 3B square. This is the value of R. This is equal to T square. What is the area of the triangle? That is equal to root 3 by 4 A square. This is the value of T. But because R is equal to T square, that would imply that 3B square is equal to root 3 by 4 A square into root 3 by 4 A square. We can cancel 3 on both sides because root 3 into root 3 is equal to 3. Or B square is equal to A square by 4 into A square by 4, or the value of B is equal to A square by 4. Or the value of A is equal to 2 square root of B. We are given the sum of the perimeters of both the triangle and the rectangle. What is the perimeter of the equilateral triangle? This will equal 3A. And what is the perimeter of the rectangle? This will equal 3B plus B, that is 4B, plus 3B plus B, so that is another 4B, or that will equal 8B. So we know that 3A plus 8B is equal to 90 centimeters. Or we can substitute instead of A 2 square root of B. So this would imply that 8B plus 6 square root of B is equal to 90. Just for ease of calculation, let us assume that square root of B is equal to x, or the value of B is equal to x square. So this equation can be transformed to equal 8x square plus 6x minus 90 is equal to 0. This is a quadratic equation. We can divide the quadratic equation by 2 because all the coefficients are even numbers. So this would imply that 4x square plus 3x minus 45 is equal to 0. Or if you are factorizing this, 4x square plus 15x minus 12x minus 45 is equal to 0. Or x minus 3 into 4x plus 15 is equal to 0. So the value of x is equal to 3. The second value of x, which is equal to minus 15 by 4, is not allowed because x has to be a positive number. So if x is equal to 3, what is the value of b? The value of b will equal x square, which is equal to 9. So the length of the sides of the rectangle are 9 and 27. This is also 9 and 27. And the sides of the equilateral triangle A will equal 2 into square root of b, or 2 into 3, that is equal to 6. So this is 6, 6 and 6. What we are required to find out is the value of 3b, which is the length of the longer side of the rectangle, which will equal 27. In this question, we are told that C1 and C2 are concentric circles such that the diameter of C1 is 2 centimeters longer than that of C2. So let us first draw two concentric circles. This is the smaller circle, so let us assume that this is C2, and this is the larger circle, so let us assume that this is C1. So we have this to be equal to C2 and the larger circle to be equal to C1. The diameter of C1 is 2 centimeters longer than the diameter of C2. So if you assume that the radius of C2 is equal to r, then the radius of C1 will equal r plus 1. Because if diameter is 2 centimeters long, radius will be 1 centimeter long. We are also told that if you draw a tangent to C2, if you draw a chord of C2 which such that it is a tangent to C1, and if the length of the chord of C1 is 6 centimeters, this is tangent to C2, we are required to calculate the diameter of C1. So let us name some points. Let the center of both the circles be equal to O. Let these points be equal to AB, and the point of the tangent be equal to C. As OC is a tangent to C2, it will be perpendicular to the chord AC. We know that the length of AB is equal to 6 centimeters. So therefore, the length of AC, which will be the midpoint, will be equal to 3 centimeters. We also assumed that the radius of the smaller circle C2 is equal to r. Therefore, the radius of the longer circle will be equal to r plus 1. Because as we have discussed earlier, if diameter is 2 centimeters longer, radius will be 1 centimeter longer. So if you just look at the triangle OAC, this is a right angle triangle. One of the non-hypotenuse sides is equal to r centimeters, the other non-hypotenuse side is equal to 3 centimeters, and the length of the hypotenuse is equal to r plus 1. In any right angle triangle using Pythagoras theorem, you have the square of the sum of the non-hypotenuse sides will be equal to the square of the hypotenuse side. Or in this particular case, r square plus 3 square will equal r plus 1 whole square. You can simplify this. This is equal to r square plus 9 is equal to r square plus 2r plus 1. You can cancel r square on both sides. Therefore, 2r will equal 8, or the value of r is equal to 4. Now, what are we asked to find out? We are asked to find out the diameter of C1. What is the radius of C1? That is, the radius of the longer circle will be r plus 1, which is equal to 5 centimeters. This is the radius of the longer circle. Therefore, the diameter will equal 5 into 2, that is 10 centimeters, which is the answer. In this question, it is given that there is an interior point in an equilateral triangle, and from that point, perpendiculars are drawn to all the three sides. The sum of the lengths of these three perpendiculars is given to be equal to S, and we are required to calculate the area of the equilateral triangle. So let us assume that this is the equilateral triangle. Let the three vertices be equal to A, B and C, and let the side of the equilateral triangle be equal to P. So AB is equal to P, AC is equal to P and BC is equal to P. Let the interior point be a point G, which lies somewhere inside. Let this be equal to G, and from G let us draw perpendiculars to all the three sides. So this will be one, this will be the other, and this is the third one. Let the lengths of the three perpendiculars be equal to A, B and C. So let this be equal to A, let this be equal to B and let this be equal to C. We are told that the sum of these perpendiculars is equal to S. So A plus B plus C is equal to S. Now we have to calculate the area of the triangle. So let us connect the point G to all the three vertices. So let us connect G to B. Let us also connect G to A, and let us also connect G to C. Now what is the area of the triangle? The area of the triangle ABC is the sum of the areas of AGC, that is this triangle, plus BGC, that is this triangle, and AGB, that is this triangle. That is the area of the triangle ABC. Now what is the area of AGC? It is equal to half into base into height. The base of AGC is the length AC, which is equal to P, and the height is equal to B. Similarly, BGC is equal to half into the base BC, which is also equal to P, into the height, which is equal to A. And the area of AGB is equal to half into AB, which is also equal to P, into the height, which is equal to C. Or the area of triangle ABC is equal to half into P into A plus B plus C. This is equal to S. This is equal to P into S divided by 2. But what is the area of an equilateral triangle? The area of an equilateral triangle is equal to root 3 by 4 into P square. So here we can cancel 1P and we can cancel 2 over here, and the value of S is equal to P into root 3 by 2, or the value of P is equal to 2S by root 3. So if you are trying to calculate the area of the equilateral triangle in terms of S, we have to calculate the value of root 3 by 4 into P square, which is equal to root 3 by 4 into 2S by square root of 3 into 2S by square root of 3. This is the area of the equilateral triangle. We can simplify this. We can cancel 4 in the denominator and root 3 in the numerator. This will equal S square by root 3.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.